Two small spheres, A and B, are moving towards each other along a straight line on a smooth horizontal surface. A has speed 3 meters per second and B has speed 1.5 meters per second before they collide directly. The direction of motion of B is reversed in the collision. The speeds of A and B after the collision are 2 meters per second and 2.9 meters per second respectively. Show that the direction of motion of A is unchanged by the collision. We should know that coefficient of restitution CRE or E, it's VB minus VA over UA minus UB for two colliding objects. These are final velocities and these are initial velocities, and CR is equal to 1 when the collision is elastically. Here is our figure before the collision and after the collision. This is our positive direction, so UB is equal to minus 1.5, and we have to decide that VA is equal to 2 or minus 2. Our statement that VA is equal to 2 meters per second, it means that the direction doesn't change. We can apply an indirect proof. Suppose that VA is equal to minus 2 meters per second. CR is equal to E. We apply this formula and substitute this. We suppose that VA is equal to minus 2 UA minus UB. It's 0.9 over 4.9 over 4.5. It's greater than 1. It's a contradiction because it's less than 1 or equal to 1. So VA is equal to 2 meters per second. So the direction of motion of A doesn't change. B. Calculate the coefficient of restitution between A and B. So we can apply this formula, and now we know that VA is equal to 2. After substitution we get that it's 0.2. The mass of B is 0.2 kilograms. Find the mass of A. So we know the velocities before the collision and after the collision. we know that this is 2, and we can use the conservation of momentum. This is the key, and after substitute we get that MA is equal to 0.88 kilograms. B continues to move at 2.9 meters per second and strikes a vertical wall at right angles. The wall exerts an impulse of magnitude 0.68 Newton seconds on B. Calculate the coefficient of restitution between B and the wall. So this is our figure. So we should know that the coefficient of restitution is equal to V over U for an object bouncing over a stationary object, such a floor. These are magnitudes. This is the initial speed, final speed. This is because, for example, the flow is the B, and its initial and final speed is 0, and for example this is our positive direction, and comes the ball to the flow. This is the initial speed, and the bounce, its final speed. And if we apply the previous formula, VA minus VB over UB minus UA, we get this formula. Here is another formula, maybe it's useful. So we need final speed and initial speed. Here is the wall, for example, the ball, and our positive direction to the left. We need final speed. We know that force is equal to change in momentum over change in time. So change in momentum is equal to F times change in time. And this is impulse. And we know this, it's 0.68 Newton seconds. And we know that change in momentum is equal to m times v minus m times u. We can substitute. We know mass, the mass, and this is equal to impulse, this value. And after calculation we get that v is equal to 0.5. So the coefficient of restitution, these are magnitudes, so it's 0.5 over 2.9, it's 0.172.